Thank you very much. This is joint work with Melanie Morton, who's sitting over here in the audience, so she can equally answer questions or bear responsibility afterwards. Okay, so this is a picture. It's a histogram. It shows the log residuals relative to the average. This is the average regency in Indonesia in terms of its average wage. And these are the residuals. This is the 50th percentile. This is 50th above. And so basically what the picture shows, which I'm doing a bad job of to start with, is the distribution of average wages across regencies in Indonesia. Okay? And so what you're supposed to see from the picture is that relative to the average regency, these regencies earn 50% more, these regencies earn 50% less. This is roughly the 90-10 range in terms of percentiles. So moving from the 10th percentile to the 90th percentile, you increase your wage by around 3 times. Okay, so these are large changes in moving across space in terms of average wages. Okay. So you can draw pictures like this for the US. It's slightly more compressed in the US. You can draw them for many, many developing countries where they're usually more dispersed. The question that we have about this picture is, can I interpret it in the following way? I take a person who is living here now, and I move this person to here. Do I increase that person's wage 3 times? If that's possible, then of course the development impact and the impact on GDP is large. Now, the main reason you might not be able to do that, of course, is selection. We don't know whether the people who are living here are the same as people who are living here. And there are a couple of reasons why you may be able to do it. So as economists, we think that there may be a spatial equilibrium, and so that people who are living here must be indifferent to living here. But there are 2 reasons why you might still be able to increase their wages by moving. One would be that the reason they choose to live here is because the amenity of living here is so unpleasant. So if I move from the lovely bucolic splendor of the outer islands of Indonesia into Jakarta, the quality of my life goes down. But that is potentially a policy variable. How do we make Jakarta a nicer place to live if it's one of these very, very productive areas? The second reason you might think that you could exploit this gap in some way is that there are just costs of moving across space. Okay, so if I live in the countryside, as we saw in Simon's talk a little bit, I have to pay quite a large cost to move to another part of the country. Okay, so what we're going to try and do in this paper is to ask a question, which is, could I increase the productivity of Indonesia in this case from moving people across space? The big reason why you may not be able to do this is selection. Once you start thinking about selection, however, it's not obvious that it only reduces the possibility of gains. Sorry, Sid.
Just related to your amenity differences, right? What about land prices as well, right? Because if you think spatially clear, these nominal wage differences could just reflect...
I'm just going to fold them all in to the amenity difference here, because we just don't have the data to do anything about it in our context. Yeah, but that's part of what I think about as amenity. If the prices of land are very high, the amenity of living there is very low. Okay. Once you start thinking about a selection, of course, it's no longer apparent that it's just the case that this person may not be able to gain to moving here. It also may be that a person living here may be able to gain from moving back to here. So somebody who's born in a city who would have been a naturally wonderful farmer may have a gain from moving back. So just looking at this diagram doesn't tell you really anything about whether or not you could make gains from moving people across space. Okay. And our main goal in what we're going to do here, this is going to be macroeconomics, and we're going to ask quantitatively how much money is on the table for moving people across space. Okay. And because it's macroeconomics, and to tie up with Ed's comment earlier about many, many ways of doing things, we're going to try and take a little bit of data that we have that covers the whole of Indonesia, and we're going to substitute a lot of assumptions to try and back out a quantitatively reasonable answer to our question. In many ways, I see this paper as a follow-up to a randomized control trial that I ran a couple of years ago with Mushfiq, where we move some small number of people from a particular part of northwestern Bangladesh into the city, and we see there that we have an RCT which shows us in some sense you can exploit this gap. right? That there are gains to moving people across space, but we don't know the answer to the general equilibrium question of how many people can we move and how big could these effects be across space. So that's what we're trying to do. And then, of course, partly we want to then say if there are large effects of moving people, can I decompose that into how much of this is driven by differences in amenities across spaces and how much of this is driven by costs of movement? This is some way towards some kind of policy answer. So we're trying to say, is it valuable to try and think about policies that help people move across space? What would be the value? And then this is saying, well, could we break that down into at least two components? Then, of course, future, you would like to try and say exactly why amenities are different. Why are there movement costs across space? Okay. So the paper, I'm going to try and do all of this in our 30 minutes, but I won't get through in detail. I'm going to start by showing some facts about migrants in Indonesia, which I think are fairly suggestive of the fact that, first of all, there are costs of moving across space, and second, that there is selection, that selection is very important. I'm going to provide a very brief overview of a theory that is consistent with the facts that I show you here. It's a theory in which there are costs of movement and there is selection. And then I'm going to use that theory empirically. I'm going to structurally estimate the model. I'm going to back out movement costs and differences in amenity across Indonesia. And then quantitatively, I'm going to try and answer the question, how much do these differences in amenities and movement costs explain in terms of Indonesia's GDP? Because I'm not going to get very far with the talk. Potentially, here are the main results. So the structural estimates are going to show us the following. First of all, that the cost of moving across space in Indonesia has gone down a lot over the last 30 years or so. The second is that the movement costs in Indonesia, even now, are much, much higher than they are in the US. Now, that's in two ways. They are absolutely higher. Second is that the correlation with distance is much more important in Indonesia than it is in the US. The third is that amenities are negatively correlated with productivity. Okay, so this is what you need for people to not want to go and live in the high productive places, and this is what we would want to find if you thought that improving amenities could improve productivity over time. A preview of the quantitative results, we do two kinds of things. First is we look at over time changes in Indonesia. Okay, so between 1995 and 2012, for example, a reduction in the movement cost that we find in the data explains about 25% in our model of the growth in GDP in Indonesia. Changes in amenities costs account for a further 25%. So this sort of reallocation across people across space over time accounts for quite a large proportion of the growth over this time. In comparison to the US is the second thing we do, and the fact that higher movement costs in Indonesia than there are in US accounts for about 5% or slightly less of the gap between the US and Indonesia in terms of GDP. So these are quite large. This is perhaps small depending on your perspective.
Clarification, you have data on amenities, or that's going to be the residual that explains
it? This is all backed out from the structural model. It's very hard to find comprehensive data on the amenities that we have in Indonesia. We have some data, and we show that there's a correlation between what we back out and things that you would naturally think are amenities like pollution. Okay, I'm not going to tell you about the literature that we're related to.
It makes sense, by the way, to hold questions to the 15 minutes at the end, because otherwise you're eating into Garrett's short 30 minutes.
So I want to say a couple of things about data. First of all is to do what we're going to do here, we need to know, we're talking about a cost of migration that in terms of movement away from where you were born. That's what we think is the relevant cost of moving across space. Therefore, in order to make our model work, I need to know where you were born, I need to know where you are currently living, and I need to know your current wage. And that turns out to be reasonably rare data, and we have it in Indonesia for 76, 95, 2011, and 2012. You can also get it for the US at a state level, so you know which state people were born in, where they currently live, and their income. Okay, so here are some facts that I want to show you which are suggestive of the model that we're going to write down. First of all, it's just basically a gravity equation for migration. So the further you move, the further the distance between two places, the fewer people migrate between those two places. Okay, so this is accounting for destination and origin fixed effects. It's what you would expect, and it's consistent with there being costs of moving across space. It is costly to move. Okay. The second fact is that this is a regression of the log of the wage of an individual as a function of the distance that they move between where they were born and where they currently live. So the further people move to where they currently work, the higher is their wage. And so this to us is suggestive of selection. So there's a cost of moving across space, which was implied by the gravity equation. Now the fact that when you pay that cost, you get a higher wage implies that you are compensated for the higher cost that you pay. And in most models, with it, competitive models particularly, you can only get compensated if you are a higher type individual. The third fact is that the more people who move from where you were born to where you currently live, the lower is your wage. Okay? So we think this is also suggestive of selection. So what we are thinking of here is that the first person to move to Jakarta is the best person to move to Jakarta. The second person to move is the second best person, and so on. And so if you have a lot of people who move to Jakarta, for example, then on average they're going to be of lower quality. Okay, so that's what a regular selection model would imply. And the third fact is that if I control for the proportion of people that move, the distance that you move is no longer important. Okay, so it's all this selection effect that is driving the distance effect. Okay, so for us this suggests a model where what happens is there is a cost of moving across space. If you're willing to pay that cost, you would only be willing to pay that cost if you are a higher type. So distance drives selection, and selection drives differences in wages across space. Okay, so there are our facts about migration in Indonesia. These facts, interestingly, with much lower, smaller coefficients on all of them, are true in the US in the data that we have as well. Okay, so now I'm not quite sure how to deal with time here, but I'm going to briefly introduce a model which captures these facts. It's quite parsimonious, it's quite easy to take to the data. It goes like this. So basically we have n locations in Indonesia, and each person born in Indonesia gets a human capital draw for each location in Indonesia. Okay, and that human capital draw is drawn from a multivariate Frechet distribution. Okay, for the academics who do trade, this is the obvious assumption to make. For policymakers, this is just an easy way for us to parameterize how to think about the fact that some people are good quality workers in IT and would be good in a city, and some people would be better as farmers. Okay, and there's a distribution of them across space. So the way it works, the way we parameterize it is that as rho goes up, people become good at everything. Okay, this means that there's a role for absolute advantage. So I am a good farmer and I am also good at IT. Okay, so this is basically an idea of talent. And as this theta tilde thing goes down, there is more dispersion across space. So there's more of a role for comparative advantage. Someone who's good at IT is not necessarily good at farming, and you would want to move people across space to where their comparative advantage is. Okay. The model then we have is basically just a Ricardian model. So the wage that you earn at location D is equal to something about the productivity at location D multiplied by your human capital that's specific to location D. Okay. We think then about movement costs in the following way. So my utility from moving from origin O to destination D is equal to the amenity of living at destination D multiplied by how much I consume and how much time I spend at home with my family, which I enjoy. Okay. And then you maximize your utility subject to the following. The amount of time that you spend away from your job, the amount of time that you spend away from your job is T hat. That has to be less than the amount of time that you have. Your consumption is equal to your wage multiplied by your human capital multiplied by how much time you actually spend at work. And then the amount of time you spend at home is equal to the amount of time you take away from work multiplied by the movement cost between where you live and where your family is. So the idea here is that if I live in London and my family is in Manchester, I give up a proportion of every weekend going home to spend time with them. It's less pleasurable. If I live across a lot of space, then it can be more costly. This is the model that we have, but we actually want to think about this movement cost here in a much more general way. It could be psychology, it could be sociology. We want to try and explain it. Okay. These models then give really rather simple closed-form solutions, and basically what you end up is the utility of someone living in location D is basically a function of how pleasant it is to move from O to D. So this is a composite of how pleasant D is, the movement costs between O and D, and the productivity of location D multiplied by your human capital. And then we get the following: the proportion of people who move from O to D is just this ratio of how pleasant it is to move from O to D over how pleasant it would be to go to any other place. And then the average human capital of someone who moves from O to D is a function of, this is just a constant, comes from the gamma distribution, and then, but it's driven by the proportion of people who move from O to D with a negative sign here. So the more people that move, the less selected they are, and as a consequence, the lower is going to be their human capital. Okay, so we can take these two equations, substitute them into each other, and linearize them, and you get the three facts that I showed to you earlier. You get a gravity equation, so fewer people will move longer distances. The people that do move longer distances will be paid higher wages, and the more people who move between location O and D, the lower will be the wage of people who move from O to D on average. Okay, so the model then replicates the facts that we showed earlier. Some facts about this which may be interesting to urban economists, I don't know, is the following. If there is no differences between two locations in their amenities and no differences, no movement costs between the two, then regardless of the productivity differences, these WD differences, there will be no wage gap. So in some sense, the fresh A distribution that we've made here returns what you would assume from most of the urban literature, that to have a wage gap between two places, you need to have some friction. That means that people can't arbitrage the wage gap away. So this is quite specific about the functional forms we have, but we think it's kind of a natural place to start in writing these models. Okay, general equilibrium, I don't know that I have time except to say that we allow for an externality. So this is an agglomeration externality. The more people that live in a particular area, the higher will be the productivity in that area. So wages just come from an assumption that there is a single maximizing firm. Okay, prices in our model come from the assumption that every location produces a unique good. Okay, and we allow for an elasticity of substitution between the unique goods that each location in Indonesia produces. We could equally think about having a Cobb-Douglas production function and limited capital mobility across space. Okay. And the final thing that we do is we allow that amenities are a function of the background amenity. This is the fact that your city has a lovely harbour, which is nice to look at, but that the more people who move into your city, the less pleasant it is to live in your city. Okay. That's the definition of general equilibrium for those that care. Okay, so identification, this is what we do to quantify the model. So we can estimate from the sorting equations that I showed you earlier, we can estimate these base wages or productivities, we can estimate the amenities, and we can estimate the costs of moving across space, and we can estimate the absolute and comparative advantage parameters from our model. Okay, this then gives us our GE solution. The things that we have to set exogenously are the disamenity of large numbers of people living in the city, we just take from the literature, and the agglomeration externality, which we also can't estimate in our model. Because some idea of where identification comes from, to identify the fresh A parameter on sorting, we basically use this equation, which says the average wage goes down as the more people move in, and that will estimate the importance of comparative advantage in our model. And the rest of the model, the rest of the parameters are identified as follows. So if you have somewhere that's a nice place to live, lots of people will move there, roughly. Now, if you have somewhere where there are large costs of moving between those two places, then both people who move from A to B will get a wage bump, and people who move from B to A. So that's roughly how we estimate the costs of moving across space. Okay. So here are some highlights of what we find out from all this machinery. Okay, so here are the costs of moving across space in Indonesia. This is for 1995, and this is 2011. You should think this is a person who would give up 50% to move between these two locations is equivalent to giving up 50% of your wage. So this is a very high cost of moving across space. You'd need to double your wage to be willing to move. Down here, you need to be increased by 0.2. Okay, so the first thing we note is that they're high. The second thing is that the costs of movement are decreasing over time. The labour markets in Indonesia, according to our estimates, are becoming more integrated over time. Okay. These, then, are the movement costs in the US from this exercise. So the first thing you notice is that they are much, much lower. They are much, much dense. They are still, not insubstantial costs of moving across space, but they're almost entirely to the left of the distribution for Indonesia. There is something odd here, which is that the US seems to have increased its costs of movement over time. Other people in the audience may be able to tell me better than I know whether this is a reasonable thing. It does fit with a fact that comes from a recent Sierra-Moretti paper that there seems to be less spatial integration across the US over time. But we are most interested in the large and stark differences in the movement costs. Okay. This then is the correlation between distance and this cost of movement that we find in the data. So this is just the straight line distance. This doesn't matter if you try something more complicated using travel times, etc. So there is quite a strong positive correlation between distance and the cost of movement in the data. That's Indonesia, and this is the US. Okay, so in the US, there is not as strong correlation between distance and the cost of movement across space. This is consistent, perhaps, with the idea that transportation is much more efficient in the US, but it's also consistent with a much more sort of psychological, sociological explanation, which is that people from the US just don't mind living far away from their families, or they are more easily able to integrate into communities which are different from them. We can't really tell what the difference is, but we do think it's stark that there is such a big difference between the correlations. These I won't show. Okay. These then are the correlations between the productivity of the location and the amenity of the location. So that we find this negative correlation. So the higher is the relative amenity of a location, the lower is the productivity of that location. And this is what you would need in order to imply that moving people across space is going to be something, changing amenities is something that could increase GDP. In terms of Steve's comments earlier, this is what you would think would happen endogenously in a model in which you had housing costs as a function of how many people who want to live there. So it's sort of natural that we find this strongly in the data. Okay. These, finally, are estimates of the amount of pollution in particular provinces in Indonesia. So this is water pollution, land pollution, noise pollution, and air pollution. And the amenities are, as you would hope, negatively correlated with these measures of pollution, which suggests that we're getting something reasonably sensible out of this. Maybe go under time, which would be exciting. Okay, so here are the counterfactuals. This is what we find in terms of what would happen if you change migration costs and you change amenities across space. Okay, I'm going to show you two things. The first is how have things changed over time in Indonesia and how does our model account for changes in GDP. The second is the comparison with the United States. Okay, in order to do these, and this is one of the things I think is interesting about a conference like this, in order to do these sorts of things I need to look at the literature and I need to parameterize my model. And I'm not going to have a lot of data that comes from developing countries to do this, and in fact I don't have a lot of facts that come from anywhere to try and do this. So in terms of the amenity spillover, this is the cost of growing the city. I think in general we don't have much data or information on what this number is across the world. We read David's paper and it suggests maybe this is zero, but there is, I would say, a dearth of information on what this is. And so this is our background, is maybe this is zero, but we're working on robustness. The productivity spillover, the agglomeration externality, there are sort of more data and more studies on this. Very few of them, or few of them, are in developing countries. But it seems the consensus is around 0.05, maybe a little bit lower than that in more recent studies. This production function, we set the CS production function to 8. There's not a lot of data on this either. This probably doesn't matter at all. Okay, so here are the results. This is what you get. So if I reduce the costs of moving across space from 1995 in Indonesia to what it is in 2012 in Indonesia, then I increase Indonesia's GDP by 8.8%. By way of comparison, in reality, in the data, it increased by 38%. Okay, so this is roughly a quarter, a little bit less of the GDP growth that we saw is, according to our model, explained by the fact that moving across space has become cheaper, and so therefore labour markets have become more integrated. These then are looking at amenity changes over time. So if we take 1995 and we say, let's say that the amenity distribution is the same as it is in 2012 in Indonesia, then our model suggests that you improve GDP by 10%. And again, relative to 38%, this is roughly a quarter of how much the GDP actually changed over time. This is, in some sense, interesting because it's by no means apparent to start with that you would think that moving to high productivity places have had an increase in amenity over time. So it's not obvious that you're going to get this out of the model. It's just suggesting that people are more happy living in high productivity places in 2012 than they were in 1995. We think it's an interesting thing to think about why the model implies that and what's happening on the ground. And the final thing we do is we need a way to say that the movement costs in Indonesia become the same as they are in the US. We do this two kinds of ways. This is the Indonesian distribution of transportation costs. What we basically do is we move the lowest transportation cost in Indonesia to be the same as the lowest transportation cost in the US, and therefore we move the whole distribution across. The alternative is we parameterize and we assume that the same correlation between distance and transportation costs exist in Indonesia as does in the US, and this will give you this distribution. Luckily, it doesn't matter which way you do this, you get the same answer roughly, which is if I change the Indonesia's transportation costs in 1995 to be the same as the US's transportation costs are now, I increase Indonesia's GDP by about 50%. Okay, so one thing is that the gap between Indonesia and the US is currently about 150, it's 15 times, sorry. So this increase is a very, very small portion of that 150 times. So you've got a comparison here which suggests that over time, labour market integration in a developing country has been very important in driving GDP growth, but that perhaps it's not that important in explaining why Indonesia is so far behind the US. Although you could take this and think that there are other things that go on with labour market integration. Once people start moving into big cities, perhaps there is more international capital that can flow in, and that's not thought about in the model that we have here. These, in some sense, are very static and don't take into account any of those effects. Okay, so having rushed through all of it, I now have actually some time to conclude. Okay, so our takeaway points here are the wages are very, very heterogeneous across space, average wages. And if this is because it is costly to move across space or because there are amenity differences across space, then there is potentially an opportunity in terms of development in improving the amenity of high productivity places or understanding what are the costs of moving across space and thinking about how to lower them. Of course, if all the differences are driven by selection, there's a lesser role for policy in terms of trying to change outcomes. In order to work out what's going on, we have this reasonably tractable spatial equilibrium model, which allows us to back out wages, amenities. It has a role for comparative advantage, and we can take into account agglomeration and congestion spillovers. And we think overall that our results suggest that migration costs and difference in amenities are, at least in terms of the development experience of this one country, very important in explaining its growth outcomes.
Wonderful.
Thank you.
Our